Welcome to this explainer on Grade 7 Robotics Unit 3. Today, we're going to master program flow. More specifically, we're going to dive right into the sequence of how code actually runs, predict some robot behavior, and, most importantly, bust a massive, completely common programming misconception. You know, when we start building structured robot programs, we tend to project human traits onto our machines. We just kind of assume they see the world exactly the way we do. But as we'll see today, understanding the exact flow of our conditionals and our code is literally the only thing standing between a brilliantly functioning robot and a very, very unfortunate crash.
So let's kick things off with a pretty simple question. Is your robot actually paying attention? Think about it. When we slap an ultrasonic sensor or a touch sensor onto our robot, we naturally assume it's going to act like us, constantly watching its surroundings, always alert and ready to react at a moment's notice. But here's the secret to predicting robot behavior. A machine only does exactly what the sequence of the code tells it to do, exactly when it tells it to do it. Without the correct program flow, that highly advanced robot you just spent hours building might be completely blind to the world after the very first millisecond of being turned on. All right, let's break down this exact misconception because it is a big one. The myth is that the robot always watches its sensors. This is what almost everyone assumes when they first learn about conditionals, like if statements. You write your code and think, hey, I wrote if there is an obstacle, stop. So the robot is obviously going to always watch for an obstacle. But the reality of the code is that the robot checks the sensor exactly once at startup. If you just drop a standard if statement into your program sequence, the code reads it one single time, makes a decision in a tiny fraction of a second, and then completely moves on. It never looks back at that sensor again. Let's actually put ourselves in the computer's shoes for a second and walk through this flawed sequence step by step. Step 1, start program. The robot wakes up. Step 2, it hits your if statement and checks the sensor exactly once. Step 3, at that specific microsecond, the path just happens to be clear, so it sees no obstacle. Step 4, it follows the rule for a clear path and decides to drive forward. And because there are no more instructions after that, it's just going to keep driving forward forever. As far as the computer is concerned, it executed your conditional perfectly. It checked the coast was clear and it hit the gas. But wait. Let's look at a classic misconception check example. Think about what happens to our robot if an object suddenly rolls into its path after that very first millisecond. Let's say, 2 seconds into the drive, someone drops a box right in front of your machine. If you ask a student to predict what the program will do, they usually say, well, the robot's going to stop. But remember the sequence we just walked through. The robot isn't looking anymore. The code has already moved on. And unfortunately, this leads us to the inevitable crash, because the program flow has already moved way past that single solitary if check at the very beginning of the sequence. All current sensor readings are completely ignored. The robot has zero instructions telling it to look again. It remains entirely blind to that new box in its path, fails to stop, and plows right into the obstacle. This is exactly why debugging robot programs is so incredibly tied to understanding sequence and flow. We didn't have a broken sensor here. We had a broken program flow. To fix this crash, we really need to turn to our Unit 3 essential question. How does program control flow make robot behavior more flexible? Because if a rigid top-to-bottom sequence makes our robot blind after just 1 millisecond, we obviously need a totally different type of control flow to give our robot the flexibility to handle a dynamic, changing environment. We need a way to tell the robot, hey, don't just check once and forget about it. Keep checking over and over again. So the absolutely crucial point here is introducing a new structure to our code. Enter the loop. A loop is a programming structure that repeats a sequence of instructions continuously until a specific condition is met. This is the exact tool we need in our robotics toolkit to force our machine to continually pay attention. By combining our conditional if statement with a loop, we fundamentally change the entire program flow. I absolutely love this analogy because it brilliantly illustrates the difference. Think of using an if statement all by itself, like looking out the window for rain exactly once, right when you wake up in the morning. If it's sunny at 7 a.m., you assume it's going to be sunny all day, so you leave your umbrella at home, completely ignoring the massive thunderstorm that unexpectedly rolls in at noon. That's our crashing robot. But putting that if statement inside a loop, that's like looking out the window to check for rain every 5 minutes all day long. You are constantly updating your information based on the current reality of the world. Let's walk through this execution pass by pass to see how our new flexible program flow actually works in practice. By wrapping our conditional if statement inside a loop, that sensor check is reevaluated on every single pass. On pass 1, the sensor reading is clear, so the robot action is to drive. But instead of the program just ending right there, the loop sends the flow right back to the top. Pass 2, it checks again. Still clear? Keep driving. Then suddenly, on pass 3, boom, the box is dropped in front of the robot. Because we're in a loop, the robot asks the question again. The sensor reading is now obstacle detected, and the robot successfully executes the stop action. Crisis averted.
This continuous reevaluation is exactly what gives us real-time reactions. The loop ensures the condition is reevaluated every single pass. And this structured program flow is what allows the robot to respond to dynamic, constantly changing conditions. By simply taking our conditional and nesting it inside a loop, we've successfully debugged our program and transformed a blind, one-track machine into a genuinely reactive robot. This right here is the true power of mastering control flow.
All right, now it is your turn to apply what we've learned. Based on everything we've uncovered today in this explainer about the myth of always checking sensors and the reality of program flow, consider this scenario. If your robot needs to constantly monitor a room's temperature and sound an alarm the absolute moment it gets too hot, exactly how should you structure that code? If you just write an if statement to check the temperature, what's going to happen if the room gets hot an hour later? How must you use a loop to ensure your safety alarm doesn't just fail after the first millisecond? Think about how you'd organize that code. I'll leave you to ponder that puzzle. Keep practicing your program flow, and I'll see you next time.